All right, hey gang. Uh, we're going to continue talking about equations of lines. Specifically, we're going to look at the slope-intercept form. And so as we work through this, I'm not going to have you do everything that I've given you. I'm going to work you through some examples, and I'm going to tell you what you need to do. So make sure you pay attention here. So taking a look at we'll start with the notes here. I think you guys can probably remember from last year, the slope-intercept form is y equals mx plus b. Don't forget that the m is the slope, and again, remember slope is rise over 1. The b is the y-intercept. Now, you might want to take a little note that the y-intercept you're always going to graph first. Graph first. Probably going to be important there. Okay? All right? So as I look at this, let's see here. Let's see. Example 1 says write an equation of the slope-intercept form for a line with a slope of -4 and a y-intercept of 3. So all we're taking is the slope was -4, so I'm plugging in for the m, slope, and then the y-intercept was 3, I'm plugging that in for the b, and that's it. Okay. So as I look down at number 1 down here, it says the same thing. So I'm going to go ahead and do this. Y is equal to the slope plus the y-intercept. Now I'd prefer you writing it like this, y equals 8x minus 3. Okay, that's really cleans it up and makes it look nice. The next one, the slope is -2 plus the b, y-intercept. So again, y equals -2x minus 1. And the last one, the slope is -1. And the y-intercept is -7, so y equals -1x minus 7. Okay, so pretty simple, pretty straightforward. I don't think there's much to really talk about with that one. For the next one, it says to go ahead and write the equations of these lines in slope-intercept form. So the two things I'm going to ask you to do when you have problems like this is figure out your slope and your y-intercept. So if I do this, here's what we're looking at. The slope, if I count it, +2, +1. So my slope is 2 over 1, or just 2. Okay. The y-intercept is down here at -2. So when I go ahead and write this out, I end up with that as my equation. Okay. Now, could you graph that in Desmos to make sure you've got the same line? Yes. Okay. So you can go ahead and do that. For number 5, as I look at the slope, +1, 2, 3, -1, 2, 3. So maybe you want to do this, +3, -3. So the rise over the run gives me a -1 slope. Okay. The y-intercept, we're up here at +3. So my equation is y equals -1x plus 3. Okay. As I look at number 6, the slope in number 6 is +1, 2, 3. Again, I could redraw this out, 3, and over 1, 2, 3, 4. So the slope is rise over run, +3/4. Okay. The y-intercept is down here at -5. So my equation would look something like this. Okay, 3/4 x minus 5. Okay, again, you can check that in Desmos. Now, the interesting part about this next part is we're just working backwards. Okay, so what I'm going to do is I'm going to first find my slope and my y-intercept. My slope is 2 over 1. That's the m. And my y-intercept is 1. So if I graph the y-intercept first, which is what we always do, +2 over 1 slope, 2 over 1 slope, 2 over 1 slope. This line right here would represent that equation right there. Okay, so again, y-intercept, up 2 over 1, up 2 over 1, down 2, left 1. Okay. For the next one, the slope is -3 over 1 with a y-intercept of 2. Okay, so I'm going to go up 2. And I can go down 3, right 1, or I can go up 3, left 1. Okay? All of these spots here would include this line right there. Okay. The last one, number 9, I'm seeing a slope of -1 right there. -1 and a y-intercept of -1. That's convenient. So -1, and again, this would be positive, negative, positive, negative, positive, negative, positive, negative, or negative, positive, negative, positive. Either way, this line right here is the same as that one right there. Okay. Whew. All right. Let's see if there's anything else to cover on the backside. I realize that was really fast. I hope that made sense to you, what we did here. Okay. So I'm going to skip right down. You can read over the notes up there. It says here, music in 2001, full-length cassette represents 3.4% of the total music sales. I would be interested to know who actually knows what a cassette is. Okay. There we go. Between 2001 and 2006, the percent decreased by 0.5% per year. Okay. So, we're going down from where we started. So it says here, write an equation to find the percent P of recorded music sold as full-length cassettes for any year X between 2001 and 2006. So 2001 and 2006, if this is years since 2001, this is actually 2001, 2, 3, 4, 5, and 6. Okay, 2001 to 2006. And we're going to go ahead and do this. In 2001, we were at 3.4%. In 2006, it looks like we are, well, 0.5% per year. So if we go down 0.5%, we're at 2.9, 2.4, 1.9, 1.4, 0.9. So I'm going to say minus 0.9% over that duration, which is 5 years. Okay, or 2006 minus 2001. Okay. Now, if we take those away per year, let's see here, this would be 2.5% over 5 years. If we divide that out by, what would that be, 0.5? Yeah, we end up getting that 0.5% per year, which is what it said right there. Okay. So write an equation to find the percent P of recorded sales. Oh, you know what? I completely misread this. The y-intercept is 3.4%. The growth rate is 0.5%. We're decreasing. So I'm going to go with the slope as a negative 0.5%. Okay. Now here's something interesting to think about. In math classes, I think you converted percentages to actual decimal numbers. If I do that here, moving the decimal 2 places to the left, 0.034 is the actual number for 3.4%. 0.005 is actually negative 0.5%. Okay. So as we do this, y equals mx plus b. That would be my equation right there. Okay. Now it says graph the equation on the grid at the right. Now that's already been done. Okay. Find the percent of recorded music sold as full-length cassettes in 2004. Well, you can do this in one of 2 ways. Years since 2004, we could put 3. Okay, or 2001, years since 2001, we could put 3 to get to 2004. So I'm going to say if I plug this in, negative 0.005 times 3 plus 0.034, okay, that should give us a value that would be very similar to this right here, which would be about 1.9%. So let's see what that looks like. Okay. I'm actually going to pull up my calculator.
Hey, Dad, there's food right there.
Okay, I know that's kind of weird to look at right there, but here's what we have. Negative. Actually, I'm going to do this 0.005. We'll make that negative. Multiply that by 3. And we're going to add 0.034. Okay, now remember we have to move the decimal point 2 places to the right to get it into a percentage. And I was right. I'm going to put down here. I'm going to put down here that this is 0.019, which is the same as 1.9%. Okay? So, hopefully I didn't confuse you with how I started out 1A right there. But, yeah, that's how you're going to work out those problems there. Now, as far as what I want you to do to finish this up, I'm going to have us go right to the practice right here. Okay? And I would like you to do, let's just do all of these here, 2 to 8. And I'm going to have you finish up the rest of the page there. Okay, 2 to 8, and do every single problem there. And I would also like you to go ahead and do, let's do 9, 10, and 11 on the back side. Okay? I think we have it good enough. Yeah. So again, 2, 4, 6, and 8, 9, 10, 11, 12, 13, 14, 15, and on the back side, 9, 10, 11. Okay? So hopefully that all is good there, folks. I appreciate you and your time. If you have any questions there, guys, come back and talk to me. As my youngest here are being a little obnoxious over there, I apologize. Anyways, have a great night, folks. We'll talk to you later.